god, that's the one I wanted. One more thing. Okay, it's finally back in stock. Okay. My cart is full.
Oh, what are you ordering?
Oh, just some things I've been wanting.
Is it Stacy? Is it Becky? Is it Keisha? Is it Ashley? Was it that?
Wait, look, the expected delivery date is glitching out, but it should be coming today. What's happening?
That's probably because there are so many factors involved. There's shipping, processing time, and the route that the delivery driver has to take. But lucky for you, Lindsay paid attention and showed up in Huzar's calculus class. Let's call her to come over. She can actually explain how math helps delivery drivers figure out the fastest, most efficient routes. I'll head off to work. My shift at the gas station starts soon.
Thank you. Okay, let me call Lindsay. Hey Lindsay, can you come over? I have some calculus questions.
Okay, so delivery companies use optimization, a key part of calculus, to minimize delivery time and fuel use. So they find the quickest route using variables like distance, number of stops, and even traffic patterns. It's all about finding the minimum value of a function.
Oh, that's actually really cool. Can you show me?
Of course. For example, imagine a delivery route where the driver starts on a freeway, which has a 65-mile-an-hour speed limit, and then exits to go on a side road, which has a 25-mile-an-hour speed limit, in order to reach their destination. So this can be modeled by a right triangle. So imagine this is the destination, and then this is the freeway, which we can label. If the destination is like 5 miles this way on the freeway, and then it's 1 mile away from this side, then we can model this length, which is x, which is how long you'd be on the freeway, and then this can be y, which is how long you'd be on the side road. So you'd want to find like the minimum amount of time. So since time equals distance over speed, you'd be trying to find, we know the speeds because of the speeds limit, so we need to find the distance. So we know the distance of this equals x, but in order to find this, you could use the Pythagorean theorem in order to find the value of y. So in this case, using the Pythagorean theorem, y would equal the square root of 5 minus x squared plus 1 squared. So using this equation, then you could make an entire function out of it. So by adding this time plus this time. So t of x would equal x over 65, which is the distance x over the speed, which is 65 miles an hour, and then plus, this would be this distance, so it would be 5 minus x squared plus 1 over this speed, which would be 25. So now you have this, which is your equation for the situation, and you want to find the minimum. So in order to find the minimum, you could use the derivative. So the derivative would be, so once you find the derivative, then you can set it equal to 0, and the x value that you would get in this equation would be 4.80. So that means that the driver should exit the freeway at 4.80 miles to take the least amount of time on its delivery route.
Thanks for showing me. That's actually really cool. I didn't know math could be used in like real world things. Maybe I should have went to class more, but thank you. Oh wait, my delivery driver is 3 stops away. Watch it hit the stall.
The way I feel right now, I feel like
Oh man, I'm out of gas. Ava, I didn't know that you worked here.
Yeah, I just started.
Alright, well I have 3 more stops in my journey and they'll be about 10 miles. How much gas should I put in?
We can use actually rates and derivatives to figure this out. A USPS ratio of gallon per miles is 1/20, and the distance Avery needs to drive to finish her route is 10 miles. So we do a simple ratio problem, which would be distance times the ratio, which would be 10 times 1/20, which would be 10/20, which would equal 0.5. So Avery would need 0.5 gallons to finish her 10 miles. That's half a gallon.
Thanks, Ava.
No problem.
Oh my god, Avery? Is that why do you have my package?
I just started working at USPS. I don't really like it, but I need the money. People order a whole lot of weird things. Sorry for the delay, I had to go get gas. Ava was actually working at the gas station. She told me how to calculate how much gas I needed. I really wish I paid more attention in math class.
Oh my god, that's so funny. Me too. I wish I showed up in class because Lindsay in our math class was just here. She was teaching me things about calc and like real world derivatives and how it goes into deliveries and stuff.
No way.
Yeah. You want to come in? I can show you what I learned.
Hell yeah.
The big idea is total accumulation. You can find the exact amount of fuel used from point A to point B without guessing or averaging the number.
Go on, I think I missed this unit.
Like sometimes when you're going uphill, you use more gas. When you're going downhill, you use less gas. And in traffic, you might idle. You can represent this function through a function called f of t, where t is either time or distance, and f of t is the rate of which you're burning gas.
So it's like tracking my gas burn rate at every second?
Exactly. If you want to find the total distance traveled from point A to point B, you use a definite integral. It looks like this.
Oh, so that squiggly S thing is just a way to add up the fuel usage over the route?
That's right. So delivery companies actually use integrals to add up the tiny slices of the 2 points A and B. That way companies know how much fuel to use even if conditions change.
So if I knew my fuel rate at every mile, I could calculate how much gas I need before I even go on my trip.
Yeah, exactly. It saves fuel, time, and makes sure you never run out of gas ever again, like what just happened.
Wow, thanks for this Calc mini lesson.
Are you gonna go to class on Tuesday?
Yeah.
Okay.
Well,
I'll see you
thanks
then.
to some good old optimization, definite integrals, and rate of change, I was able to bring your package as fast as possible. Here's your baby oil and Michael B. Jordan pillow.
Thanks. This is a little awkward now.
I'll be going. Okay.
Hey guys, thanks for watching our calculus video. Today you learned how optimization, rate of change, derivatives, and definite integrals are concepts used in calculus and in math class and could be applied into real world things like USPS deliveries.
Yes, every time I make a delivery, those are all the things that I use. Just to preface, we cleaned up all the boxes. We did not litter while making this video. And
Yeah.
I'm sorry to the guest appearance. I hope you enjoyed my delivery to your house.
Thank you for watching. Bye. Thanks, Mr. Huzar.
I hate my job.